everyone, welcome back to my channel EduVibe. Today we'll start with another topic of the Unit B of grade 11 chemistry, which is the third combining gas law. So we do the Boyle's law when we do with the pressure and volume only. We do the Charles law, we do it with the temperature and the volume. Now we do the combined gas law where we include the pressure, volume and temperature all together. But we use that relation, directly proportional, inversely proportional of the gas laws to put that in the combined gas law. So for this, the combined gas law states that the product of the pressure and volume, so product of the pressure and the volume sample is proportional to its absolute temperature in Kelvin when the chemical amount remains constant. So basically what they're talking about that your PV is that product of pressure and volume, which is P times V, is directly proportional to the temperature. So temperature is this, and when the chemical amount of gas remains constant, which is your N, and that we use in the next lesson in the next law, which is ideal gas law. So in this, we just know this thing: the product of PV is directly proportional to the temperature, which is T. And in this too, we have the formula made. So in this, we do the product of P and V. So we do P1 times V1 upon T1, P2 times V2 upon T2. That all you that initial pressure, final pressure, initial volume, initial temperature, and final temperature. That's all things remains the same. Make sure the pressure and the volume has the same units over there, and temperature must be in Kelvin. And the variable that is constant may be eliminated from a combined gas law. Anything which is a constant in that thing, if you have anything constant, just go to 1, this the value of is 1, and then go eliminate from the equation. That's all we're caring about. So in the first question we have, states that the steel cylinder with a fixed volume contains a gas at a pressure of 652 kPa and a temperature of 25.0 degrees Celsius. If the cylinder is heated to 150.0 degrees Celsius, use the combined gas law to calculate the new pressure. So basically, we have to calculate new pressure, and we have initial pressure. So that this is a P1, and we have to find the P2. Also, we have two temperatures. At P1, the temperature is 25.0 degrees Celsius, which is your T1, and that temperature when they heat it 2, so it's T2. And they're talking about that they will have a fixed volume. They're not talking about the volumes anymore. They're talking about that volume is fixed. If the volume is fixed, if anything is constant, that means the volume is if it's fixed. So it means that V1, if it is 1 liter, V2 is also is 1 liter. So it gave 1 liter and 1 liter of this. If you make the variables we have to find, so we have a what's the formula for this? We have a P1 V1 upon T1 is equal to P2 V2 upon T2. What do you have to find? We have to find P2. So when you convert this, you get P1 V1 upon T2. That all should multiply. And from here, just V2 and T1 goes to denominator to find P2. That's all we do. So P1 is 652 kPa. V1 is 1 liters. And your temperature. Now the temperature you have to be in Kelvin. So T1 is 25.0 degrees Celsius plus 273.15. You get about 298.15 Kelvin. For T2, T2 is 150.0 degrees Celsius plus 273.15. You get about 423.14 Kelvin. So 423.14 Kelvin. Divide this by 298.15 Kelvin, and your V2 is again 1 liter. That both cancel out. Kelvin also cancel out. So for P2, when you find it out, you get about 925.3 kPa. You want this in 3, say this, so 325 kPa. So that's your P2. So that's a kind of a long calculation. So must be you have to put the when you put the insane calculator, you must care of the multiplication and the division. So that's the long calculation you have to do in this type of things. So that's all you have to do, and you get the P2. You have to just recognize that in the question which is given to us and which is you have to find, which is initial, which is final. You have just known this. So in the next question, we have again one question for this. So sample of argon gas occupies a volume of 2.0 liters at minus 35 degrees Celsius and the standard atmospheric pressure. What would the Celsius temperature be at 2.0 atm, and if is the volume decreased to the 1.5 liter? So what's the talking about? So we have a volume which is that initial volume which is 2.0 liters. This is the initial volume of this. So we have a V1 and we have minus 35 degrees Celsius, which is your T1, and you have to be in like Kelvin, so you have to plus this by 273.15 and you get about in positive 308.15 Kelvin. And a standard atmospheric pressure. Standard atmospheric pressure means STP. So in STP, your pressure should be the different. What is the pressure in that case? So in that case, you have to be in your formula sheet. You see that your pressure is given to us STP, and we have discussed this when we do temperature and pressure. That at this point, when we have a STP, we have some temperature and some we have a pressure too. That pressure is recognized as a P1. So for this thing, your P1 at this STP is 1.01325 kPa. So P1 is given to you. P2, we have to find the Celsius temperature. We have to find the T2 in this. So T2 have to be found. And the pressure second is 2.0 atm. That 2.0 atm should be converted into kPa because this should be in kPa. Or you can convert this into atm, or you can convert atm into kPa. But that is easy to convert this. So for P2, 2.0 atm into 1.01325 kPa, this divided by 1 atm. So 1 atm cancel out. You get a P2 of about 202.65 kPa. So get this in kPa and this is also in kPa. So your things are managed. And the volume decreased to 1.5 liter, which is your V2. Now we just find out for T2 in Celsius. We have in Kelvin. At the end, we have to convert this into in Celsius. So P1 V1 upon T1, P2 V2 upon T2. So that's the thing, and you have to find the T2. This goes over there. So P2 V2 T1 divided by P1 V1 is equal to T2. So T2 is equal to, what is P2? 202.65 kPa. V2 is 1.5 liters. T1 is 308.15 Kelvin. This whole divided by the P1, which is 101.325 kPa, and your V1, which is 2.0 liters. Liter cancel out, kPa cancel out, and now you have to do just put things and multiply this, then divide it by this, you get the answer, and this is the long calculation. So be particular about the things you calculate in your calculator. So you get 357.225 Kelvin. Again, you have to minus this by 273.15 to convert this in Celsius. So T2 is equal to about 84.075 degrees Celsius. You be in like 2 set this, which is 84 degrees. So that's your volume. For the lot of thing you have there. As I told you that sometimes you get in tape kPa, this is atm. So you have to convert this. So to convert atm to kPa is easy, so I convert this into this. Then you put in this, and that's the answer. So it's 84.0 degrees Celsius. So that's all work you have to do for this question to get the answer. In this law, you get the long calculations. So that's all for this lesson. We left with only one topic, which is ideal gas law, and we now introduce to the N, which is the chemical amount of gas. So in the next lesson, we do that. So for now, learning lesson with EduVibe, learn smarter but not harder. Please like, share, and subscribe to my channel. If you have any questions, let me know in the comment section. See you in the next lesson. Till then, stay creative with EduVibe.